Welcome back to our Common Core Algebra 2 series. Tonight's topic is also on dividing polynomials, but with a different method. This is called reverse tabular method to dividing polynomials. So before we get into dividing polynomials, let's remember how to multiply with the tabular method. So if I want to multiply these two factors together, we can distribute or use the tabular method. And the tabular method simply makes a table. So this would be a 2 by 3. So I'm going to make 3 columns and 2 rows. And on top I'm going to say this is x squared with a positive 5x and a positive 1. And then I'm going to call this side 2x and plus 5. And the tabular method was really nice. Basically all we did is we went this way and this way where they met, and we multiplied those two terms together. So 2x times x squared became 2x cubed. It's a little sloppy. 5x times 2x became 10x squared. 1 times 2x was 2x. Then this bottom left-hand corner, I'm going to get a 5x squared plus 25x and a 5. And then what we did, as you'll recall, is we basically went through and we added the diagonals. So this diagonal comes out to be 2x cubed. These two we're going to put together. So 10x squared and a 5x squared make a 15x squared. Then these two diagonals, 25x and 2x, make 27x. And these are positive, so I'm going to put plus signs there. And then this last diagonal just makes a plus 5. So what does this tell us? Well, it's telling me if I multiply the factors 2x plus 5 and x squared plus 5x plus 1, I get, and I'm just going to follow here, 2x cubed plus 15x squared plus 27x plus 5. And that's how our multiplying worked on our tabular method. All right. Now let's try to use the tabular method to divide these two polynomials. So here's how we're going to begin. We're going to put the divisor on the right-hand column. So I know I need a 2x and a positive 5. And then we have to figure out how many terms are going to go across. Now here's how I think of it. If I have 2x and I want 2x cubed, what am I multiplying by? Well, hopefully you're saying an x squared. So if I'm going to use an x squared, that means I'm going to have basically an x squared term, an x term, and then a constant term. So that's telling me I need 3 boxes going this way. Okay, and now I'm going to put the solution in. So remember, this first box I want to be 2x cubed. Then these two boxes together are going to make 15x squared. These two boxes that line up, 27x, and then this last box, a positive 5. Okay, so here's how it works. You know you want your answer to be 2x cubed here, so you always start in this upper left-hand corner. And you say, if the answer is 2x cubed, 2x times what gets me 2x cubed? And hopefully you're saying that's x squared. So x squared times 2x makes 2x cubed. Okay, now that you know what this upper term is, you can easily get this one because you have the x squared and the 5, and when you multiply those, you get 5x squared. Okay, so now I'm going to go up to this corner because I know together, and I'm going to try to circle them and not make too much of a mess, this term and this term have to total 15x squared. Well, if you already have 5x squared, what would you add to it to get 15x squared? Hopefully you're just saying 10x squared. Now that those check to make 15x squared, I can go get this upper box because 2x times something has to be 10x squared. And I'm going to say that's 2x times, grab a different color, 5x. And just verify 5x times 2x makes 10x squared. So now that I know this is 5x and this is 5, I can go get this box down here. That's going to get me 25x. Okay, so now I'll work the diagonal again. If this is 25x and something else with x has to make 27x, what do you think that something else is? Hopefully you're saying 2x. And again, I'll just verify 2x plus 25x makes 27x. Now I can go get this last term. I'm saying 2x times what is going to get me 2x? Well, that's just a positive 1. And again, now that I know this is a 1 and this is a 5, if I multiply those, I should get my last term to give me 5, which is what I wanted in the end here. So I can see that each of these diagonals adds up to exactly what it's supposed to be. And that's our first look at the tabular method to divide. Now if that went a little too fast, again, it's at your fingertips. Pause it, rewind it, and listen to it again. But of course, we'll go through a few more practice problems. All right, let's try another one. Divide 2x squared plus x minus 10 by x minus 2. And again, we'll use the tabular method. So setting the box up, the x minus 2, so I'm going to have an x and a minus 2 on this side. Okay, so I know I only need 2 going across. Now I have to figure out how many boxes I need going up and down. And it's pretty easy. Basically, again, I'm just saying x times what would get me the 2x squared? Well, I would say that would just be 2x. So I need an x term and then a constant term. So I know I just need 2 boxes here. All right, and I'm going to put my solutions in. This box is going to total the 2x squared. These 2 boxes will total the x, and this last box will total negative 10. And I know that I want my first box to be 2x squared, because that box has to total 2x squared, and there's only one there. So now we just start. X times what gets me the 2x squared? Well, I'm just going to say that's 2x, and just verify it for yourself. 2x times x, 2x squared. Check, you know it's right. Now you can use this 2x and this negative 2 to complete this box. So I would say 2x times negative 2 is negative 4x. Okay, so now I'm going to focus on this diagonal. This box compared to this box needs to total x. Well, I currently have negative 4x. What would you add or subtract to get a positive 1x? I would say that would have to be a positive 5x. And just, again, double check it. 5x minus 4x is 1x. Okay, so now I can get this box here, or this term here. X times what is going to get me 5x? Well, I would say that would just be 5. And now that I have this 5 and negative 2, I know my last term is going to be negative 10. And look, that one matches up, and we know we're right. So what does this tell us again? Well, 2x squared plus x minus 10 divided by x minus 2 equals now what we get up here, 2x plus 5. And just like we did with the long division, we can take our 2 factors and make sure they multiply out to what we wanted. So I can say the 2x plus 5 times the other factor is x minus 2, and I want that to total the 2x squared plus x minus 10. Well, I'm just going to carefully FOIL it out and see what I get. So 2x squared minus 4x plus 5x minus 10. Again, I just FOILed. That gets me 2x squared plus x minus 10, and that was exactly what we were trying to prove. All right, let's try another one. X to the 4th plus 4x cubed plus 3x squared plus 4x plus 2 divided by x squared plus 1. Now, take a notice that it goes 4, 3, 2, 1, and then we have our constant, so that looks great. Those degrees are in order. But this guy, do you notice the divisor is missing a term? It goes x squared to the constant. It's missing that x term. So just like we talked about in long division, we're going to use 0 as a placeholder. So on my side, I actually need to go x squared, and then 0 x's, and then my positive 1. Okay, so I'm going to have 3 rows there. Now remember, to figure out how many columns you need, you're just saying x squared times what will get you x to the 4th. Well, you know that's an x squared, so you're going to need an x squared, an x, and a constant. So I'm going to need 3 going this way. All right, so we're just going to put the solutions in those corners. So I'm going to say this first box is going to make the x to the fourth. And I like to put these diagonals in to remind myself those two are going to come together to make 4x cubed. I'm going to use a different color. These three are going to come together to make 3x squared. Again, I'm just going to switch my colors up. These two will come together to make the 4x. And then lastly, this last guy is going to turn into a positive 2. All right, so remember, the first box is the easy box, the upper left-hand corner, because it's the only one there. X to the fourth, it has to be x to the fourth. Okay, so now I say, one more time, I'll walk you through it. X squared times what will get you x to the fourth? Okay, so hopefully you're saying x squared. And now that you know this one term, you can fill in all these boxes straight below. So x squared times 0x makes 0x cubed. Did you catch that? You're really multiplying by 0, so you don't have any. So I'm going to say that's 0x cubed. And then x squared times 1, of course, is just x squared. Okay. So now I'm going to focus on these guys. I know this has to total 4x cubed, and right now I have 0x cubed. So what do you think this box has to be? Hopefully you've guessed it and said, well, if I don't have anything and I need 4x cubed, it's got to be 4x cubed. Okay, so now I'm going to go back and say, now that I have this box here, x squared times what gets me 4x cubed? Well, we know the number for sure is a positive 4, and I need an x times x squared to get x cubed. So again, now that I know this, I can fill this whole column in. So I'm going to say 4x times 0x. Notice that 0 is there, so 0x squared. And 4x times 1 just gets me 4x. All right, so let's go to this upper corner. All right, I'm going to look at this, or I'm going to kind of circle it for myself. I know these have to total 3x squared, so what do I currently have? I have 1x squared and 0, so that's a total of 1, and I need to make 3, so I know this term has to be 2x squared. Okay, so now I'm going to go get this top piece. X squared times what gets me 2x squared? Well, I would say that's just going to be a positive 2. Notice these are positive, so I'm going to put plus signs there. And now again, since I know this, I can fill in the rest of this column. 2 times 0x, well that's nice, that's just 0x. And then 2 times 1 is 2, which I love to see because those match up. So one last time, what did we do this for? Well, we just figured out that this polynomial divided by x squared plus 1 gets me this polynomial, x squared plus 4x plus 2. So that tells me that the factors are x squared plus 4x plus 2 and x squared plus the 0x plus 1. So if I were to multiply this out to check myself, use that distributive property or tabular, whatever you prefer, you should get the original polynomial that we started with. Alright, so I've got a big bear for you. Look at this 5th degree polynomial that we have to divide. Okay, so we need to find the quotient between these two terms, and obviously quotient is implying that we should divide. So, this flipped classroom works best when you really pause it and try things on your own. So my suggestion for you is to pause it and just set up the box. Just make sure you can set up the tabular part. So pause it, see what you've got, and then hit play and see if you followed, if we've got the same thing. Good luck. So here's my setup. See what you think. This said x squared plus 4, so I knew the middle x term was missing. So I had to go with a degree 2, degree 1, and then the constant. So I knew I needed 3 here. Then I said to myself, look at the leading coefficients. X squared times what gets me x to the 5th? Well, I said that's an x cubed. So picture this, I need an x cubed, which means then I need an x squared, and then an x, and then a constant. So I knew I needed 4 across the top. Okay, so now, and then of course, I put all my solutions in, and I'd like to do it in colors just to keep things straight for myself. Alright, so I'm ready to begin. Like I said, if you think you've got this, pause it, try it on your own. That's the best way to see if you're successful at it, and we really encourage you to do that. So pause it, go for it, and see what you get. So here's what I would do. If you were truly honest with yourself and you paused it, I would kind of just scroll through to the end and see if it matched. If it did, you're in great shape. If it didn't, turn it back on and see exactly where you made a mistake, because I will talk it all out. So here's my explanation. I know this first term needs to be 3x to the 5th because there's only one box here and it has to total 3x to the 5th. Okay, so now I'm going to go to the side. X squared times what got me 3x to the 5th? What do I want this to be? Well, I would say that would be a 3 and an x cubed. Okay, so 3x cubed times x squared is 3x to the 5th. Now I can fill this whole column in. So I have 3x squared times 0x, which is going to be 0x to the 4th. And then 3x squared times 4, 12x cubed. Now I'm going to go work my way where my blue dashes are and say, okay, these boxes here have to total negative 2x to the 4th. Well, I currently have 0x to the 4ths, so this would have to be a negative 2x to the 4th for that to total. Now I'll say to myself, x squared times what would get me negative 2x to the 4th? Well, I would say that's going to be a negative 2 and an x squared. And again, negative 2x squared times x squared is negative 2x to the 4th. Now I can fill this whole column in. So I'm going to say this gets me 0x cubes, and negative 2 times 4 is going to be negative 8x squared. So now I'm going to take my yellow dashes and I can get these boxes all together. I have to total 6x cubed. Right now I have 12x cubed and 0x cubed, so that's really nothing. So 12x cubed and what will get me 6x cubed? I'm going to say that should be a negative 6 x cubed, because 12 minus 6 gets me 6. So now I can go get this top piece. X squared times what gets me negative 6x cubed? I would say negative 6x. So now we'll fill this row in. So negative 6 times 0x is going to be 0 x squareds, and then negative 6x times 4 would be negative 24x. Okay, so now I'm just going to circle the row I'm talking about here, and I guess I'm going to use the black marker, and say these have to add up to negative 4x. Well, I currently have negative 8 and 0, and I need a negative 4. So negative 8 plus 4x squared would get me a negative 4x squared. And now I'll just go get this last term, and hopefully I end up with a 16 if I did this all right. So x squared times what is 4x squared? I would say a positive 4. And then this would get me 0 x's. And then lastly, I got 16, which matches perfectly. And I'll just quickly verify 0x and negative 24x got me that negative 24x there. So again, what did I find when I did all this? Well, I found the factors that actually divide this polynomial. So the two factors, so let's just jot them down for ourselves, are 3x cubed minus 2x squared minus 6x plus 4, and, ran out of room here, x squared plus 4. So if I wanted to prove that that was accurate, I could do my distributive property, multiply all those out, or the tabular method to show that I get what I started with, this huge 5th degree polynomial. Well, again, feel free to go back and rewind and do what you need to do, and we'll look forward to some great practice tomorrow. Have a great night.